Hello and welcome to this video for Chemistry 20. We are in the stoichiometry unit, and today we're going to learn or review, because I already looked at this lesson back in the gases unit, something called the law of combining volumes. So far in stoichiometry, in my previous videos, we've looked at gravimetric stoich, which involved using masses, and solution stoich, which involved using concentration and volumes. Remember, in those questions, our 4 steps were to write the balanced equation, find the moles of the given with either mass over molar mass or C times V, find the moles of your wanted by applying the wanted over given balancing coefficients, and then find the final answer, whatever it is you're looking for. Well, the law of combining volumes is an exception to those 4 steps, okay? And you can use this formula only if you have gases that are at a constant temperature and pressure. Okay, so it only applies to gases. That's the key here. Okay. If it doesn't mention temperature and pressure, we're going to assume that it means that they are at a constant value. So what you're going to do is, actually there's only 2 steps in these calculations. Again, starting with a balanced equation, write your information given, identify your wanted and given, but then you don't have to convert it into moles. You can actually apply the wanted over given values directly to the volume, okay? So all I have to do is use my mole ratio wanted over given to the volume. I don't have to find moles. And then that is my final answer. That's it, okay? So if you have gases at constant temperature and pressure, you can use the law of combining volumes. Let's look at an example, and then that's it for this video. So here's the following reaction. We have 1 mole of nitrogen gas. Nitrogen gas is diatomic, so by itself it has a 2, reacting with 2 moles of oxygen gas to produce 1 mole of N2O4 gas. Now again, we're not given a temperature or pressure, so we can assume that means it's constant. And in fact, all I'm given is a volume. So the only thing I really can do is apply the wanted over given to the volume, because there's no other information to do any other calculations. So let's look at our information and identify our wanted and given. It says that we have 2.5 liters of nitrogen gas. That is therefore my given. The volume of my given is 2.5 liters. And we are looking for the volume of oxygen that is consumed. Consumed means it's reacting. So oxygen is my wanted. So to find the volume of my wanted again, all I have to do is take the volume of my given and multiply by the ratios, balancing coefficients wanted over given. So that would be 2.5 was my given volume, times 2 over 1. Right in front of my wanted, there's a 2. In front of my given, there's a 1. So that means the volume of my wanted, which is the oxygen, is 5.0 liters. And that's it. So law of combining volumes is kind of a shortcut stoich calculation where you can apply the wanted over given ratio directly to volumes. Again, only you can do that with gases, so you have to have something in a gas phase and no mention of a temperature or pressure changing, so you can assume they're staying constant. Sig digs, again, look at the question. There's 2 here, so I need 2 total digits in my answer, 5.0. That's it. Thank you for watching this video.